Hi, myself Pradeep Sakamuri, me along with Sunil Gurla working on DLH final project. We're working on a paper called Bidirectional Temporal Encoder Network to predict the medical outcomes. Our group ID is 19 and paper ID is 13, and then the difficulty level of the paper is hard. So here the general problem that what we're trying to solve is like predicting medical outcomes using EHR data. So in general, the patient's EHR data is a three-level hierarchy with patient journey, capturing all the experience of the diagnosis and the treatments over a period of time. And then the next level is the individual visits, a set of medical codes in a particular visit. And then finally, we have this medical code, a specific record in the form of medical codes. So the proposed BiteNet model, which is bidirectional temporal encoder network, is based off self-attention mechanism and mask encoder as its major component. And the major shortcomings of a RNN approach for predicting medical outcomes is that as the patient sequence grows, the RNN struggles with vanishing gradients and forgetfulness due to the low memory constraints, so which results in drop in prediction accuracy. So the proposed BiteNet model captures both contextual dependencies between the patient's journey and also the temporal relations within the patient's journey. So here we are using Mimic 3 dataset with for so here let's look at the model architecture. The embedding layer is applied to the input medical codes of the visits and its outputs is processed through the stack of n mask and n blocks with the diagonal mask and the code level attention layer to generate the visit embeddings. Similarly, the visit interval encoding are then added to the visit embeddings, followed by a two parameterized united stack encoder, mask encoder block with forward and backward masks. So this visit level attention layer is applied to the outputs followed by the concatenation layer and followed by the feed forward neural network, which has a softmax as its output layer, which is giving the probability score of critical distribution of the target categories, uh, define like predicting what kind of illness the patient could have. Here, let's look at the reproducing steps. So we are using TensorFlow 2.0 as the framework for developing the model, and then we use 1060 GTX NVIDIA GTX card for with 6 GB RAM as for the compute training compute. And when we started training the model with the parameters given or presented in the paper, we are not hitting, we've seen that the numbers are, the precision and accuracy numbers are actually not matching with the published numbers. So we had to do a lot of fine tuning and try to understand what are the parameters that are influencing the accuracies. So, and then we came up with the list with the numbers that are shown here with the base size 128 and then different embedding size and multi-heads and different epochs for diagnosis and readmission. And on the right, you can see the instructions of the command line arguments that we have seen to do the training and then perform the evaluation. And in total, we have approximately trained the model for like 50 plus iterations to conduct the experiments and the ablation study. And then we used 8 plus hours of GPU time, train time. So here, this table shows the initial numbers of baseline versus the BiteNet. So we generated the baseline models with changing the model parameter in the code. So here finally the results we are comparing with the bar chart. So here you can see the BiteNet actual versus reproducer results for diagnosis prediction with DX only. So here the actual is 0.82 and we have seen 0.81. Similarly with the DX and TX we are seeing 0.83 and 0.80 as actual and reproducer results for DX and TX for diagnosis precision. And then similarly for the readmission precision accuracy, when with ODX only we are seeing 0.3266 as the actual number, but we achieved 0.32727, which is very close to the actual number again. And similarly for DX and TX, we have achieved like much better performance by fine tuning the parameters than the actual published numbers. Yeah, thank you.